4-4, factoring quadratic expressions. So in this section, our objective is to find common and binomial factors of quadratic expressions and to factor special quadratic expressions. And what you need to know is that we can factor many quadratic trinomials like ax squared plus bx plus c into the product of two separate binomials. Okay? And that's what factoring is. We're going to split my standard form quadratic into two separate terms, two separate binomials. Okay? So let's start here with this little quick game. Okay? You see two cards shown on the right. You get the other two cards with numbers, any numbers. And you're going to win if, number one, the product of two of your numbers equals one of these two numbers, and the sum equals the other number. Okay? So if you think about this, we're trying to figure out what two numbers multiply together to give you 5 and then add together to give you 6. Well, the two numbers that I could think of that multiply together to give me 5 and add up together to give me 6 is going to be 1 and 5. Okay? The other way, if we think about the two numbers that multiply together to give me 6 and add up to 5, if I think about this, that would be 3 and 2. Okay? So in both of these cases, 1 times 5 is going to be equal to 5, and then 1 plus 5 is going to be equal to 6. 3 times 2 is going to equal to 6. 3 plus 2 is equal to 5. And those are the techniques that we're going to use when we want to try to factor an expression. Okay? So, the factors of a given number are the numbers that have a product equal to that number. Okay? Factors of a given expression are expressions that have a product equal to the given expression. So when we're talking about factoring an expression, that is just rewriting an expression as a bunch of things multiplied together. Okay, and that's what factoring it is, separating it into its different parts. Okay, so when we multiply binomials together, we use two methods, either the distributive property or the FOIL method to multiply two binomials. Most of the time, I'm going to talk about the FOIL method. Okay, and when we factor, we're going to use FOIL in reverse to help us. So if we look at the first example here of the distributive property, we see x plus 4 times x, and then x plus 4 times 2. So both of these first terms times both of these second terms. Now, when we talk about the FOIL method at the bottom, we see that we have first, outside, inside, and last, FOIL. Okay? And when we multiply all those terms together then and combine them, we are going to get a trinomial that looks like x squared plus 6x plus 8. Okay? So let's practice with the FOIL one time. Okay? So let's FOIL these two binomials together. I call them binomials because each of them has two terms. Okay? So let's do it. First terms. So that's going to be 10x squared. Outside, it's going to be the 5 times the 1, which gives me 5x. Inside gives me negative 6x. And then the last, which gives me negative 3 times negative minus 3. Okay? Then, what you should notice is that these two terms are going to get combined. So my answer becomes 10x squared minus x minus 3. So just looking at this trinomial, these three things, I can kind of see my last term, and I can kind of see my first terms. Okay? And I can see that, yeah, 5 times 2 gave me the 10x squared, and 3 times 1 gave me the 3. But just looking at my answer, it's hard to tell where the two middle terms came from. And that's going to be the trick when we try to go back the other way, when we try to go in reverse, okay, is to figure out how the middle terms combine to give me whatever I have in my answer. Okay? So, going back to this example right here, okay, when we look at that, when we look at x squared plus 6x plus 8, think of FOIL in reverse when we want to factor it. Okay, so find two binomials for which the first terms have the product of x squared, which can only be x and x. Okay, the products of the outer and inner terms have a sum of 6, and the last terms have the product of 8. Okay, so that's what we're talking about here. Two numbers that multiply together to give me 8, and when I add them together, I get 6. And I can see that it is 4 and 2, because 4 times 2 is 8, and 4 plus 2 is 6. Okay? And you might want to make a table of all the factors as a way to help you decide which one is the right answer. Okay, so factoring ax squared plus bx plus c when a is plus or minus 1. So when a is plus or minus 1, remember that a is the number in front of x squared. So when that number is a plus or minus 1, factoring is a lot easier. Okay? How do we do it? Well, we want to look for the numbers that multiply together to give me 20, and when I combine them, they give me 9. And in this case, I know they're both going to be positive, so I'm going to add these numbers together. So I want the factors of 20 that add to 9. And you can see if I look at the 20 and sort of work backwards, I can figure out how to say this expression, the factors of 20 that adds to 9. So if I want to figure this out, find all the factors of 20. That's 1 and 20, 2 times 10, 4 times 5. And I can see that 4 times 5 is 20, and 4 plus 5 is 9. So now that I know what my two factors are, now I can figure out what my first term is going to be. Okay, just had somebody come in, so I totally forgot where we left off. But if we're looking to find the factors of 20 that add up to 9, right, we got 4 and 5. Okay, so let's make my factors. And I know that I want my first two terms to multiply together to give me x squared. So I know my first two terms both have to be an x, which is why factoring with a 1 in the front of x squared is a little bit easier, because my first two terms are always going to be x. Okay, now I know that I want to multiply positive 4 and positive 5. And I can check my answer with FOIL. Okay, x times x gives me x squared. Outside, 5x and 4x together give me 9x, and 4 times 5 gives me 20. Okay, so when you get your factored answer, you should always double check with FOIL to make sure you're doing it correctly. Now, with this one, notice the difference here. In this case, we have a positive and a positive. So now I'm looking for the factors of 20 that add to 9. Okay? Well, with this problem, with problem B, I want the factors of 72. Now they're going to subtract. Because if you think about it, when you have two things that multiply together, they either have, if they're the same side, positive and positive, you get a positive. If they're negative and negative, you get a positive. So the only way I could have this last term be a negative 72 is if the signs are different. And when you have two terms that have different signs, you subtract them. This tells me that I'm going to get a positive 14 when I combine them, which means the bigger number, the number with the bigger absolute value, is going to be positive. Okay, so now I can list my factors of 72. 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. Okay. Looking down this list of factors, I want a pair of them Well, I know that the bigger absolute value number has to be positive. That means that all of these are going to be negative, which means that when I combine two of these, when I add them together, I'm going to get a positive 14 right there. Negative 4 plus positive 18 gives me a positive 14. So, setting up my two binomial factors, okay, I have a x squared in the front, which means that both of my first terms, again, have to be an x. And now I know that I have a minus 4 and a plus 18. And when I FOIL this out, this is my answer right here. When I FOIL it out to check, I have x squared plus 18x minus 4x minus 72. So that works. Okay. And those two factors would be my answer. Okay. This also tells me, again, that both signs have to be different and the bigger number is positive. Both signs are different. The bigger number is positive. Okay. For the last one, the last example here, the problem with this term is that it has a negative in the front. So problems with a minus 1, when a is minus 1, are a little bit different. Okay? We never want to have x squared be negative. So I am going to factor it out, which means that if I factor out a negative from positive 13, it turns into negative 13x plus 12. And now I can factor this the way I did the first example. Those are the factors of 12 that are going to add up to a negative 13. Well, because 12 is positive, it means that both of my factors have to be negative, because a negative times a negative is going to give me a positive. So I'm going to have negative 1 and negative 12. And I can see from right there, without even having to go any further, that adding these together give me a positive 13. Or sorry, give me a negative 13. Writing my factors, of course, remembering that I still have a negative out front. This is not an equation. This negative sign does not just go away. All right? So we need to leave it as part of our factored form. If this was equation equal to 0, like we'll see later, then I could have multiplied both sides by negative 1, and it would have gone away because it would have canceled with the 0. But for now, we have to leave it. My first terms are an x, and I have a minus 1 and a minus 12. So I have my answer in factored form. And of course, if I were to check it, if I were to multiply it, then I would get back to my original answer if I were to FOIL it out. Okay. Next, the greatest common factor, the GCF, is a common factor of the terms in the expression. Okay. It is the common factor with the greatest coefficient and the greatest exponent. You can factor any expression that has a GCF not equal to 1. So what this means is that if you can see a common factor inside of an expression, factor it out. We might not be able to factor it like we did the ones on this page. We might not be able to factor it into two binomial factors, but we might be able to factor it a little bit. Like this problem. That problem has no term at the end. It has no constant term. So we're never going to get this to factor like a two binomials, okay? Because it's not a trinomial. But I do notice that they have some things in common. They have a 3 in common. They also both have an n, which means they have an n in common. So I can take that out, okay? And when I take that out, I have to figure what is left over. So if I divide 6n squared by 3n, I get 2n plus divide 9 by 3, and we get 3. If I want to check, distribute this back in. Do I go back to where I started? Yes. And that would be factoring out the GCF because their common factor was 3n. Here, we do have a trinomial, but it doesn't have a 1 in the front. It has a 4 in the front. So we'll see how to factor this in a minute, But for now, I should notice that not only does this have a 4, but they are all divisible by 4. That means 4 is a common factor. Before you start doing some methods that we're about to learn, you should try to make it easier. You should try to make it an easier problem. So factor out the 4, and then we'll see what's left over. And x squared plus 5x minus 14. So now I have the factors of 14 that subtract to 5. Or I can think of it as two numbers that multiply together to negative 14, and when I add them together, I get a positive 5. Okay? This is going to be, well, I can list all the factors of 14. 1, 14, 2, 7, and that's all of them. I know that because 5 is positive, that the number with a bigger absolute value has to be positive, which means these two have to be negative, and combining these two gives me a positive 5. Okay? Now, of course, don't lose the 4. So we have 4 times my two factors, which are going to be x minus 2, x plus 7. Foil that back out to double check. Okay? Good. Next, factoring a trinomial when a is not 1. Okay? So when we're going to factor this, we're going to have to rewrite there's a couple different ways to do this. Okay? Let's look at 3 simple methods to factor anything when a is not equal to 1. Okay? The first method is called the factor method. Okay? This is a method where you list all the factors of the first term and all the factors of the last term, and you see how they can go together to give me the middle term. Okay? So let's do it. The factors of 2 are 1 and 2. The factors of 12 are 1 and 12, 2 times 6, and 3 times 4. Okay. Now, remembering how FOIL works, these two are going to multiply together to give me my first term. And we know that both of these are going to be a plus because we have a plus in both places. Okay, so we know that my first terms are going to multiply together to give me 2x squared. And I only have one set of factors. So that means this has to be a 2x and this has to be an x. Or the other way around, that doesn't matter. Okay. Now, the trick is to figure out what goes in the other two positions in order for me to multiply the inside pair and the outside pair and add them together to get 11. Okay? So my trick is to work through all these different factors. Okay? So I can do, well, let's start with this first set right here. I could put a 1 there. I could put a 12 there. Does that work? My inside term is 1. My outside term is 24. 1 and 24 does not give me 11. That doesn't work. So let's get rid of it. I could do this way. 12 there and a 1 there. Now my inside pair is 12. My outside pair is 2. That's a 14. That doesn't work. Which means that this pair is out. So I now go to the next method, or the next set of factors. Okay. Trying these, put a 2 there, put a 6 there. That's 2 and 12. That's not 11. Next, put a 6 there, put a 2 there. That would be 6 and 4. 10, close, not 11 though. That's out. All right. Finally, we have 3 and 4. So plugging in a 3 there and plugging in a 4 there, my inside term is 3. My outside term is 8. 8 and 3 is 11. This is my answer. Okay? So this is kind of like a guess check method, trying all the different pairs of factors. And you can see that as we get more and more factors on each side, this becomes more and more difficult. Okay? And sometimes when I do this, you'll see that I make connections like this. Okay, 2 times 4 gives me an 8. 1 times 3 gives me a 3. 8 and 3 give me my 11. Okay, these two terms go in my first positions, 1 and 2. These two terms go in my second positions, 3 and 4. And the 3 has to multiply with the 1, which means it is in opposite parentheses, different parentheses. You can never multiply something, when we're FOILing, you never multiply the two terms in the same parenthesis. Okay? So that's the factor method. Let's do the same problem over again. Let's try something called the grouping method. Okay? This method takes a different approach. In this method, we take, my first step is to take these two terms, the first term and the last term, and multiply them together to give me 24. Okay? Now what I do is I list the factors of 24 that add, because this is a plus, that add up to the middle term, 11. So I want the factors of 24 that add up to 11. 1 and 24? No. 2 and 12? No. 3 times 8? Yes. Okay? So what I do now is I change 11x into 3x and 8x. So rewriting my equation, 2x squared plus 3x plus 8x plus 12. Okay? I haven't really changed anything. All I've done is broken the 11x into two different parts. Okay? Now what I do is now I look at these first two terms and the last two terms, and I factor out something they have in common, with the goal of having whatever's left over be the same in both terms. Okay, so let's see how I can do that. In the first two terms, the only thing they have in common is an x. What's left over is a 2x plus a 3. In the last two terms, they both have a 4 in common. And what's left over? 2x plus 3. Now, because of the distributive property, if I'm multiplying x and 4 by the same thing, I can rewrite this as two sets of factors. X and 4 is the first set, 2x plus 3 is the second set. And notice that I got the same answer. Different order, but that doesn't matter because of the commutative property. Okay. Let's do that one more time. Okay. The last method is the Berry method. This method is a little strange, but it takes sort of the concept of factoring with grouping, and it does a little logical jump here. Okay, so we're going to start this the same. 2 times 12 is going to be 24. Okay, so I want the factors of 24 that add to 11. I'm not going to list them all again. I know it's 3 and 8. So with the Berry method, what you do is you start with the first term in both parentheses no matter what. So we have 2x, and then we use both of these terms, 2x plus 3, 2x plus 8. Okay, well, now you should see that 2 times 2 for my first term gives me 4x squared. So in this case, I'm over by a factor of 2. Okay, so let's hold on to that for a minute. I should see that that term has a common factor. In fact, it has a common factor of 2. So let's pull it out. And I'm left with x plus 4. And now rewrite this one, 2x plus 3. And my over factor of 2 and my extra factor of 2 cancel out. So I've placed an extra factor of 2 into this problem to write it down a little bit easier, and then I canceled it out at the end. Okay, that's the Berry method. Okay? Just taking, instead of trying to group these things, instead of splitting 11x into 3 and 8, all I do is rewrite both binomials with the 2x squared at the beginning, and then I can cancel it out later. So, 3 different methods to choose from. Factor method, guess and check. Grouping method. Multiply the first and the last terms. Grouping method is good. The problem is that when you multiply the first and the last term, sometimes that number can get very large. So you got to be careful about that. And then the Berry method is also the same problem. This number can get very large, and you just have to remember to eliminate the overage. Whatever factor you are over by, you have to cancel that out at the end. Let's try a different problem. Okay, completely different problem. Okay, we'll go with the factor method and maybe one other method. Okay, so my factors of 4 are 1 and 4, 2 and 2. My factors of 3 are 1 and 3. Now, however, I want my answers to subtract to 4x. Okay, so when I do this, I now have to figure out what goes here. Okay, so 1 and 4 don't work, so that means I have 2 times 1 is 2, 2 times 3 is 6, and I want it to be negative, so when I combine them, I have a 2 and a minus 6. So both of my first terms become 2x and 2x. I have a plus 2 and a minus 6. And it doesn't really matter where the 2 and the negative 6 go because we have a 2 in the beginning of both. Let's do grouping. So 4x squared minus 4x minus 3. Multiply the 4 and the 3 together. I get a negative 12. So my factors of this have to be 1 and 12, 2 and 6, which do subtract to 4 if the 6 is negative. Okay, those combine to give me negative 4, positive 2 and negative 6. So now I split minus 4x into plus 2x minus 6x minus 3. Haven't done anything except to split negative 4x into 2 different terms. Common factor there is going to be a 2x. What's left over? X plus 1. Whoops. No, it is not. It's going to be 2x plus 1, which means that I definitely made a mistake over here. And of course I did. That should not be a 2. That should be a 1 because these 2 last terms, and that should be a 3. Sorry about that, guys. Okay, so when I multiply the last terms, we better get 3. Not these 2 numbers. We should get 1 and 3. Okay. I should go back and do this all over, but I'm not going to. Anyway, back over here. So now we can factor out a negative 3. And I have 2x plus 1. Okay. Which makes my 2 factors 2x minus 3 and 2x plus 1. Which now they match up. Okay. All right. So let's finish this off with 2 special types. Okay, 2 special types of two special types of factoring methods. Okay, the first is when we have a perfect square trinomial. Okay, that's a trinomial. That's the square of a binomial. Like for instance, x plus 5 squared. That gives me x squared plus 10x plus 25. Okay, notice that in order to tell this, then ax squared and c are squares of the terms of the binomial. Like x, if I square that, I get x squared. 5, if I square that, I get 25. Okay? They both have to be positive no matter what. Okay? That's the way a perfect square trinomial works because you're squaring x and you're squaring 5. Okay? And then the middle term, because we're doing this twice, think of x plus 5 squared like x plus 5 times x plus 5. So when I want my middle term, I have my inside and my outside terms, I have both 5x. So bx, the middle term, is going to be twice the product of x and 5. X times 5 is 5x, and I do it twice because I have one 5x in the inside and one 5x on the outside, which gives me 10x. Okay. If b is negative, it would be x minus 5 squared. Okay? So if we look at my two perfect square trinomials, I can see that if I have a positive there, I have x plus b, a plus b squared. If I have a negative, I have a minus b squared. And these are real, very, very helpful if you can notice whether or not the trinomial is a perfect square trinomial. It will help you factor very, very quickly if it is. Like this problem. First of all, we could factor this exactly the way it is right now, but because this is a perfect square and this is a perfect square, and this is 2x squared, this is 6 squared, 2x times 6 times 2 gives me 24x. Okay, so I know this is a perfect square trinomial. But before I even get started with that, in any of these problems, you should immediately notice that all of these things are divisible by 4. So you should take that out first. X squared minus 6x plus 9. Okay? And notice that I also still have a perfect square trinomial because x times x gives me x squared, and 3 times 3 gives me 9. And so x times 3 times 2 gives me 6x. Okay? So that means this can factor into, don't lose the 4, x minus 3 squared. Okay? Recognizing perfect square trinomials will help immensely when you go to factor. One other special type of factors is the difference between two squares. Okay? That's when you have a perfect square minus another perfect square. Okay? When you do that, you have a pattern to the factors. Okay? It becomes a plus b, a minus b. And notice what happens. A times a is a squared. Outside, that's negative ab. Inside is plus ab. And then last is minus b squared. Okay? So notice that these two cancel out, which is why we have a squared minus b squared. And it's always a squared minus b squared anytime we have the difference of two, or sorry, anytime we are multiplying real numbers together, we can only get a squared minus b squared. Later in section 8, we'll see when we can have the sum of two squares and how to factor that using imaginary numbers. But for now, when we have the difference of two squares, we can factor it with this pattern right here. Okay? So let's take a look. Are these two perfect squares? The answer is yes. That's 5x times 5x, and that is 7 times 7. Okay? So when I factor this, because it's the difference of squares, it factors as 5x minus 7, 5x plus 7. And that is 4-4, factoring quadratic expressions. Sorry for the mistake earlier.